reaction. Recalling them, we have synthesis, decomposition, and single displacement. In synthesis, we form only one product. In decomposition, the exact opposite of synthesis, we break down that single reactant or single compound. And then in single displacement, you have one element that replaces other element in a compound. Okay, so you have to make use of this reactivity series of metals or reactivity series of nonmetals for you to predict, for you to predict the or answer products in any single replacement reaction. Okay, we'll continue. We'll discuss the last topic, last type of inorganic chemical reaction, that's double displacement, or also known as double displacement, replacement, or metathesis. The reaction only involves switching of ions. You switch the position of cations and anions. Let's say, for example, in the given general formula general equation below, you have the substance AY. It is reacted to a compound BX. This is just a general equation, ha. Uh, you treat this two substances as either ionic compounds, or this could be acids or bases. Again, AY or BX in the reactant side could be ionic compounds, acids, or bases. Okay, so in any ionic compound, acids, or bases, it always consists of a positive pole followed by a negative ion. Okay, so you have a positive followed by negative ion. Let's recall ionic compound, diba? It consists of cation followed by anion. So let's say, for example, AY, the A there is the cation, then Y is the anion. Same goes with BX. B is the cation, X is the anion. And based on the definition of double displacement, we simply switch the position of the ions. You can focus with the position of cations. You switch the position, let me change the color. Ayan, switch the position of atom A, and atom B. You switch them. That's why you produce the products BY and the other product AX. So you switch A and B, meaning you switch the cations. As you switch the cations, you are at the same time switching their anions. So you can just focus on the cations. Okay, kasi after you switch again the cations, you are also at the same time switching their anion. So that's the concept of double displacement. Let's say, for example, so all the given reactions in the slide are double replacement or double displacement type of reaction, because observe on the reactant side, the substances being reacted are all ionic compounds or bases, acids. But that's the components on the reactant sides for double displacement. You are reacting ionic compounds, acids, or base. Okay, so let's make use of the concept of double displacement to predict the products. What could be the possible products out of this reaction? So let's have number one. You have the chemical substance silver nitrate reacted to sodium chloride. Now, in this first reactant, silver nitrate, it's very obvious that silver is a metal. So that is the cation form, the cation portion of the compound silver nitrate. Then the nitrate ion is the anion portion. Then for sodium chloride, Sodium is the cation, then chloride is the anion. What did I told you? Kapag double displacement, you switch the ions. You can focus with the cations. You switch the position of the cations. Then you can predict the products. You can answer what are the possible products for this chemical equation number one. So meaning to say, in replacement of silver here, you now have sodium. So you extract the ion form of sodium. Okay? So sodium is Na plus, followed by nitrate. You can now write the chemical formula of one product, and that is sodium nitrate. What's the other product? Look at what happened in replacement of sodium sa sodium chloride, it will be replaced with silver. So you extract, what's the ion form of silver? Silver is Ag plus, followed by chloride. Then, crisscross method. You will produce the other product, silver chloride. Okay, so you really have to familiarize yourself sa ionic formulas for you to, aside from naming, writing chemical formula, also in writing chemical equations like this, predicting products. Okay, so that's it. Now, the first type of chemical reaction, yes, generally it is a double displacement, but specific, kapag specific type of reaction yung tinanong, this is an example of precipitation type of reaction. Why? If you perform this chemical reaction in the laboratory, let's say you have silver nitrate solution, you react that with sodium chloride solution, it will produce this precipitate, color white precipitate. So if the chemical reaction forms or produces a precipitate upon reaction, then specifically it is a precipitation type of reaction and it follows double displacement concept. Okay. Next, number 2, sodium hydroxide, hydrochloric acid. Class, if you encounter any chemical formula of compounds containing OH, hydroxide, they are structurally, chemically, bases. Okay, kapag naman acids, they contain H+, diba? That's the condition, a component, meron lahat ng acids, they always contain proton or hydrogen ion. So that's the difference between components of acids and components ng base. Kapag hydroxides, bases, if they contain proton, then acids. Since acids are proton donor, so they should contain proton. Okay, let's predict the products. So this is a double displacement, generally, na type of reaction. So we switch position of sodium and hydrogen because, again, cations are the ones being switched in position. Okay, then once you switch the cation's position, you are at the same time switching the anion's placement. Okay, now in replacement of sodium, in sodium hydroxide, you now have hydrogen ion, followed by hydroxide. Okay, any compound containing two hydrogen, and one oxygen, that will form a stable compound, water. So never will happen na you write the chemical formula of water in this way, HOH, upon crisscross method. Because you know this is a basic information. Even a student not learning chemistry, they know the chemical formula of water. It's always H2O. So again, do not write it in this manner. That is not correct. Okay, so it should be H2O. So that's one product. Then what's the other product? So in replacement here of hydrogen in hydrochloric acid, you add sodium ion. Again, they just switch in position. Sodium ion followed by chloride ion. So you have to extract the ionic formulas nila for you to obtain the correct chemical formula of the products. Okay, so you have sodium chloride. Okay, another information, kindly take note, if in a chemical reaction, acids are being reacted with bases, that is specifically known as neutralization type of reaction. It's quite easy to understand, diba? If you react an acids and bases, you are neutralizing the solution. Okay, so acids base, neutralization, and the constant product, you always form water and an equivalent salt upon reacting the acids and base. So the equivalent salt formed in this specific type of chemical reaction is sodium chloride. Okay. So still it follows double displacement concept, switching of ions, cations, anions. Okay. So the third, again, you have cation, anion, you switch the position here of potassium and aluminum. Okay? So in replacement of potassium, aluminum na yung nandyan. And what's the ion form of aluminum? Aluminum is Al3 plus, yes, followed by nitrate. So criss-cross method, you will produce the product aluminum nitrate. So you enclose in a parenthesis the polyatomic anion before writing subscript greater than 1. Okay. Then in replacement here of aluminum, you have potassium. So potassium ion is K plus, then chloride ion, Cl negative. So the other product is potassium chloride. Okay, next. Number 4. Barium chloride, you have to learn how to read chemical formula. Given the formula, you name it. Barium chloride plus magnesium sulfate. So you have barium and magnesium. You switch the position of barium and magnesium as the cations. So in replacement of barium, you now have magnesium. Magnesium is Mg2 plus, followed by chloride ion. Chloride ion is Cl negative. Crisscross, you produce the product magnesium chloride. And what's the other product? In replacement of magnesium, you have barium. You write barium ion followed by sulfate. Okay, and what's the chemical formula of barium sulfate? You simplify, no? Simplify the chemical formula, equivalent cancel out lang yung opposite charges with the same numerical value, which is 2. So cancel them out, equivalent to 1 yung subscript. Barium sulfate is PaSO4. And then lastly, you have sodium sulfide reacted to ferrous chloride. So same thing, you switch the cations, sodium and ferrous or iron. So in replacement of sodium, you now have iron. Iron is 2 plus. Given this formula of ferrous chloride, so the ion of iron here is the 2 plus, the one with the charge 2 plus. Followed by sulfide. Sulfide is 2 negative. Okay? So you will produce the product ferrous sulfide. The other product is sodium. Yes, sodium chloride. Okay? Are you following? Can you show a thumbs up if you understand the concept double displacement? Okay. That it's easy to predict product if you really memorize the ions, the ionic formulas. Okay. Sige, number 6. You have sodium bromide. Sodium bromide followed by barium chloride. Switch again the cations. So in replacement of sodium, you now have barium. Barium is 2 plus and bromide is Br negative. So crisscross method, you produce one product which is barium bromide. So Br2. The other product, instead of barium chloride, so diba, you switch the sodium and barium position. You have now sodium ion followed by chloride ion. So the other product is sodium chloride. Sige, let me continue. 7 and 8. So you have silver nitrate and magnesium chloride. So switch again the cations. Cations are in red color. But of course, in the exam, same color lang yung fonts, ha? This one for your guide lang during your independent study. So the cations are the ones written in color red. Okay. So in replacement of silver, you have now magnesium. Magnesium is 2 plus followed by nitrate. Nitrate is NO3 negative. Okay. So the other product would be magnesium nitrate. Okay. And then continue. The other product aside from magnesium nitrate is silver chloride. Ayan. And last. The last example is specifically neutralization, another neutralization type of reaction. Diba? Observe that sulfuric acid is reacted to a base, which is sodium hydroxide. If it contains OH, it is a base. Then, if it is reacted to acid, then neutralization happens. And what's the product kapag neutralization? You produce salt and water. So automatic, there is a water as part of the product. But what's the salt equivalent formed out of reacting sulfuric acid and sodium hydroxide? Sige, let's try to find out. Switch the ion, hydrogen ion and sodium ion. So you have now sodium ion followed by sulfate. Sulfate is SO4, 2 negative. Ayan. So this is the salt equivalent that you will form if you react sulfuric acid and sodium hydroxide. So that would be sodium sulfate. Okay. And of course, the other product is obviously water because the reaction again is neutralization. Any neutralization reaction, part of the product is water. So let's extract how water is formed. Again, in replacement of sodium, you now have H plus, meaning the hydrogen ion from the acid, then followed by hydroxide. So the stable compound that you will form out of this is water. Okay, so that is all about double displacement. Okay, sige. So this one, I discussed this already. Again, to reinforce information, neutralization is reacting acids and base. And the product, a salt and water. That's the reason why it is also known as salt formation because on the product, upon reacting acids and base, it forms a salt. That's why it is also synonymous to the reaction salt formation. Any question about double displacement, neutralization? Kindly show a thumbs up if you have no clarification. Okay, sige. So we'll continue. This time, if you know already how to write chemical equations, predict products from a chemical reaction, then you are ready this time to balance. You need to know how to balance chemical equation, and it's quite easy to balance, no? If you know how to count and you know how to add and multiply. That's it. That's the foundation in balancing. First, by the way, why is it important to balance chemical equation? This actually applies the law in the fundamental law in chemistry, the one we discussed in part of our lesson one, yung law of conservation of mass. You remember when you say law of conservation of mass, the mass before and after the chemical reaction, it remains the same. Okay, so by balancing chemical equation, we can realize here that the masses on the reactant side is just equivalent to the masses upon forming the products in a chemical reaction. Okay, so let's try to balance. No? Sige. What are the considerations that you have to take note in order to balance any chemical equation? First, count. Count the number of atoms of each element, both in the reactant side versus that of the product side. Do not be confused, ha? Where is the reactant side? Where is the product side? Reactants are always on the left. Okay, reactants. Then products are the substances being formed after you react. Substances written on the right side of the chemical equation. After the arrow, those are the products. After you count the number of atoms of each element, in the reactants and product side, you use whole numbers. Make sure the smallest possible whole number coefficient in order to balance chemical equation. Okay. Then lastly, for polyatomic ions, what are examples of polyatomic ions? Example, hydroxide, poly, more than one. Now, more than one atomic ions. Another example, sulfate, nitrate, and the rest of the polyatomic ions, if you observe these polyatomic ions as part of the chemical equation, you just count them as one element. You treat them as one element upon balancing chemical equation for you to easily balance, no, the equation. So let's try to go back with these uh, chemical equations wherein we predicted earlier their products, diba? This time, our focus is balancing these equations. So let me erase first the writings. Sige, let me erase first, ha. Give me time to erase para we have spaces to balance them. Okay, let me write again the product. Product, we have barium, bromide, sodium chloride. I will just write it again. Then you have magnesium nitrate and silver chloride and okay, sodium sulfate and water. Okay. Again, the focus this time of our discussion is to balance. No problem with predicting the products. We're done with that concept, how to predict products. Okay, this time let us balance. Given the considerations written here, we'll make use of this concept, considerations, in order to balance these three chemical equations. Okay, so let's have the first one. Based on the first consideration, you simply count. Count the atoms of the elements you can observe in the reactants and also in the product side. So you have to list down what are the elements that you can observe in the reactants and on the product. So list down natin. Let's start with, on the left side, you have sodium. So you try to list it first. List down the elements. So you have sodium. Look at the reactant side, it has sodium. Also on the product side, it has sodium. So that is one atom of the element. Next, bromine. Both sides has bromine. So bromine on the left, bromine also on the right. So list it down. Followed by, what else? Barium. Barium on the left and barium on the right. And lastly, chlorine. Chlorine on the left, chlorine on the right of the chemical equation, meaning on the reactant side and on the product side. So these are the four atoms of the elements you can observe in the first chemical equation. And again, based on the consideration, we have to count how many sodium in the reactant, how many sodium in the product side. So that's the first thing that you should do in balancing. Sige, let's try to count, starting with sodium. In the reactant side, on the left, there's only one sodium. How about on the product side? Same, only one. Try to compare ha. Bromine, focus on bromine. On the left, bromine on the left of the equation contains only one. What about bromine on the right side, on the product side? How many? Sige, your turn. How many bromine you are seeing on the product side? Okay, there are two. Next, barium. How many barium on the left side? You have one, meaning on the reactant side, there's only one. Then barium on the product side, one. Chlorine, focus on chlorine. Class, we're now on chlorine. How many chlorine on the left side? You have two, meaning on the reactant side, there are two. Then on the product side, there's only one chlorine. Okay, so that's the first thing. You should do counting. I believe you know how to count. Okay, now try to observe what are the atoms of the elements that are not balanced. So I already encircled. What are the atoms in the chemical equation not balanced? We have bromine and also chlorine. So you proceed with balancing. How will you balance it? Based on the considerations written, we use whole numbers. Whole numbers as in no fraction, no decimals. Only whole numbers are accepted when you write coefficients to balance chemical equation. And make use to use the simplified, the smallest denominator, the smallest coefficient. Okay, so first, let us balance bromine in both sides. So in the product side, there are two. Now on the reactant side, we have to increase it to make it two. What coefficient you need to multiply on this atom in order to make it equal to 2 as well, para equal na yung reactant and also the product side. So obviously, you will use the coefficient, the smallest possible coefficient, which is 2. Okay? Now look at the reactant side. Where is bromine on the reactant side? It is part of sodium bromide. So meaning to say, you need to write a coefficient of 2 before the chemical formula sodium bromide in order to make bromine equivalent to 2 on the left, on the reactant side. So balanced. Bromine is now balanced. Now, after you write coefficient of 2 before the chemical formula sodium bromide, the atom sodium is affected, right? After you write 2 here, the mathematical operation here is actually times. Okay? 2 times 1 atom of bromine, so 2. That's why balanced already yung bromine at both sides. What about sodium? Sodium atom is affected. The number of sodium atom on the reactant side is now equivalent to, obviously, 2. So you also multiplied 2 coefficient in the atom sodium on the reactant side after you write 2 here. So that is equivalent to 2. So meaning to say, sodium and also chlorine are now the atoms not balanced at both sides. Look at sodium. On the product, there's only 1, di ba? When we count it initially. So again, we balanced it. You have to look for coefficient. What coefficient you should multiply on that atom of sodium to make it equal to 2 as well. So that reactant side and product side for the sodium atom is now equal to 2. So obviously you write here coefficient of 2. Let me erase this part so that we have spaces. So barium bromide, then the coefficient. Ayan, 2. So again ha, this time sodium at both sides is now balanced. The sodium atom is now balanced. So you have to reflect it. On the product side, di ba? On the product side, you use the smallest coefficient of 2 to make it also equivalent to 2 on the product side. So you have to reflect it on the chemical formula where you can observe sodium atom. So it is part of sodium chloride. Now, class, try to observe. After you write coefficient of 2 before sodium chloride, you also affects the number of chlorine on the product side. So meaning to say you also multiplied 2 on the atom chlorine on the product side. That's why this time, my question is the chemical equation now balanced? Yes or no? Okay. So it is now balanced. Balance all the atoms at both sides, reactants and product side, equal na yung number. So that's how you balance it. So let me enclosed in a box, the balanced chemical equation. So you need 2 moles of sodium bromide to be reacted to barium chloride, producing barium bromide and 2 moles of sodium chloride. So that's the balanced equation. Second, we have silver nitrate. Okay. Now, silver nitrate reacted to magnesium chloride and producing magnesium nitrate, silver chloride. So let's balance the chemical equation. So you have to list down. Ganun pa rin, list down the elements, atoms of the elements observed in the equation. So you have silver at both sides. Ayan, silver, silver. Excuse me. Next, look at the ion nitrate. Diba it is a polyatomic anion. So you can just list it as one element. Count them as one element. So nitrate, NO3. Because you are observing at both sides NO3, also on the product side, NO3, at both sides, reactant and product side. So you can just write it NO3. Okay? And then magnesium and chlorine. Now let's try to count how many silver, nitrate, magnesium, and chlorine in both sides. So silver, reactant side 1, also in the product side 1. Nitrate, NO3. Wala namang subscript, di ba, na naka-enclose dyan sa NO3. So isa lang yung NO3 sa reactant side. On the product side, there are 2. NO3 may subscript na 2 naka-enclose. Kumbaga, ang buong the whole polyatomic anion is enclosed in a parenthesis with a subscript of 2. So there are 2 NO3 on the product side or nitrate on the product side. Next, magnesium, both sides the same, and chlorine not balanced at both sides. So 2 in the reactant side and 1 in the product side. Okay, let's try to start balancing. You can start with nitrate. Nitrate and chlorine are not balanced. So the same thing what you did in the first equation. We use a multiplier of 2 here to make nitrate at both sides equivalent to 2. So where's nitrate? Part of silver nitrate on the reactant side. So you write 2. After writing 2, you affected the number of silver, right? Now this time, silver on the reactant side is also equivalent to 2. So this is not balanced anymore, no? So you have to balance silver at both sides. So you increase the number of silver on the product. Look at the product side. Silver is only 1. So you have to multiply 2. Let me change the color. Ayan, multiply 2 to make it also equivalent to 2. So this time, you have now equal numbers of atom silver at both sides. So you write here 2. Class, after you write coefficient 2 before the chemical formula silver chloride, you affected the number of the atoms chlorine on the product side. So here's chlorine. You multiply coefficient also of 2 equal now to 2 at both sides. Question, is the equation balanced this time? Yes or no? Okay, it is now balanced. This is the balanced chemical equation. Okay, let's proceed with the last example in balancing. Let's have sulfuric acid reacted to sodium hydroxide producing sodium sulfate and water. So let's focus on balancing. Sige, list down. List down the elements. So you have hydrogen. Okay, hydrogen on the reactant side. We also have hydrogen. Remember water? Let me break down water, ha? Diba remember water here is formed after we combine hydrogen ion with hydroxide ion. That is the derivation where we derived H2O. It came from one hydrogen ion and one hydroxide ion. Correct? Let's recall. Remember, after you switch the ions, hydrogen ion and sodium ion, in replacement of sodium here, you have now H plus and OH. This is where water came from. Okay, that's why I break it down there on the product side. Okay, ayan. So again, it came from one H plus, one H, and one OH. So meaning to say, uh, at both sides, it contains hydrogen. Also, aside from hydrogen, it also contains hydroxide at both sides ng equation. Sa reactant side, it has an OH. Also, on the product side, where is the OH? It is part of the compound water. Okay? Next. Kasi you might be confused. Ma'am, on the reactant side, there is hydroxide. And you are just seeing here H2O. You try to break it down. Break down where this water came from. Remember, it came from one OH and one H. Okay, so you can still observe OH on the product side. It is part of water. Next, let me change the color. What else? Sulfate. So after hydrogen, you have SO4, sulfate at both sides of the equation. You have in the reactant side and here on the product side. And lastly, you have sodium. Okay, at both sides, you are observing sodium atoms. So these are the atoms you can observe in this chemical equation. Let me finish this discussion. I know it's already time. Sige. Let's balance this equation. Count. Count first how many hydrogen on the reactant versus on the product side. Remember class ha, we break down the water compound here into 1H, 1OH. Ito, 1H, then yung isa, isang OH. We need to count also OH. Okay. So on the reactant side, there's two. Sorry, there are two hydrogen. On the product side, this is your bases ha in counting. H and OH. Oh, my question, how many hydrogen sa product side? Again, break down natin. We break down, yes, very good. We break down water into H and OH, so there's only one, H. Okay? Sulfate. Sa sulfate, on the reactant side, you have one, and then SO4. Yung buong SO4, there's only one. It is not enclosed in a parenthesis. Therefore, there's only one polyatomic anion sulfate. Also, in the product side, there's only one SO4. And then sodium, 1. On the product, 2. Okay, hydroxide, 1 on the reactant, then 1 on the product side. Again, this is the basis ha in counting. Okay. Sige, let's balance. Encircle the atoms not balanced. So you have hydrogen and sodium. So you can start with the first listed atom. So you have hydrogen. So you multiply a coefficient here to make it 2. So that would be 2. So meaning to say, in this uh, water chemical formula, you write a coefficient of 2. So meaning to say there are now 2 H. Focus on H ha, the one that we break down. Okay? Sige, so there are 2 H already, so balance, no problem with hydrogen. Now, after you write coefficient of 2 before the chemical formula H2O, you affected the number of OH on the product side, meaning there are also 2 this time. Total of 2 na hydroxide. Okay? So you need to balance also hydroxide at both sides of the equation. Okay? So you try to balance it. Multiply 2 on the reactant side to make it also equivalent to 2. So where is hydroxide on the reactant? Part of sodium hydroxide. So you write coefficient 2 before sodium hydroxide because that's the compound where hydroxide can be observed. That is the element that we balanced. Okay? Now, after you write 2 before the chemical formula sodium hydroxide, you affected the number of the atom sodium as well on the left side, on the reactant side. So you also multiply coefficient of 2 on the atom sodium. So that makes it equivalent now to 2. Okay, so that's how you balance it. So I will just give simple equations on balancing. Just know the basics. That's the most important thing, knowing the basics in the given concepts in chemistry. Because again, you are not enrolled to applied chemistry or BS chemistry. You're a student pharmacist, so you just have to learn the basic concepts on general chemistry. We'll focus more on pharmaceutical, inorganic compounds, the pharmaceutical uses of compounds. So that would be part of midterm topics. Okay? So any question about balancing? Balancing chemical equation. Can you show a thumbs up if you follow the discussion? Okay.